learn Euler's form of complex numbers. Now the first question we are going to solve here is e to the power I e to the power iz plus e to the power minus iz whole thing divided by 2 is equal to cos of z. This is what we have to show. Now we know from Euler's form that whenever it is e to the power I theta, it is cos theta plus I sin theta. Now this form we are going to use for the both the terms individually. Now for the first term, it will be cos of z plus I sin z for the first term. For the second term, cos of z minus I sin z. Okay, so this negative cos of negative theta is positive cos theta, whereas sin of negative theta is negative sin theta. Cos is positive, whereas sin is negative. I'll write it here. Sin of negative theta is negative sin theta, whereas cos of negative theta is cos of theta. Therefore, the cos will remain positive, whereas sin will change its sign to negative sign. Now, these two will get cancelled, so you end up getting 2 cos z whole thing divided by 2. Now, the 2 and 2 can be cancelled here, so you end up getting cos of z. That is what we have to prove here. Okay, so next they are asking us to find the value of cos of 2i. Now, cos of z we found out to be e to the power iz plus e to the power minus iz whole thing divided by 2. So what will be your value of cos of 2i? Wherever z is there, put 2i. So you end up getting e to the power I times 2i plus e to the power minus I times 2i whole thing divided by 2. So e to the power minus I minus 1 into 2, I square happens to be minus 1. So there plus in place of I into I is I square. So in place of I square, we are going to put minus 1. So minus 1 times 2 is minus 2 plus minus into minus. So it will become e to the power of 2 whole thing divided by 2. Now use your calculator. Shift e to the power of minus 2 plus e to the power of 2. Answer divided by 2 happens to be 3.7621. 3.7621, but the question says round off to three significant figures. So three significant figures is first three digits of non-zero numbers, so 3.76. So next digit is 2, so you can ignore the 2 and 1. So this is your final answer. Now let us do the second one, sixth question here. The sixth question is 5 to the power of I. Express this in the form of x plus I times y. Now we all know that e to the power of I theta happens to be cos theta plus I sin theta. Now if there is any other constant apart from e, can be written something like this: e to the power ln of 5 to the power I. Hope this is clear. We can always write like this: whenever a number is there, we can write it e to the power of ln of the same number. So 5 can always be written as e to the power of ln 5. So you end up getting the same thing, nothing wrong. So this I can come down here. So you'll end up writing e to the power I times ln 5. So this, now we know that e to the power of I theta is what? Cos theta plus I sin theta. So the same thing we are going to write now. So cos of ln 5 plus I sine lan 5. Now use your calculator to get the value of lan 5, cos lan 5 and sine lan 5. So cos of lan 5 minus 0.038 plus I sine of lan 5 0.99. Okay, so either it is in this form or any of this answer is right. Either this also or this also is right. Okay, so let's go to the next question, seventh question. Now you have 3 to the power 2 minus I. 3 to the power 2 minus I. This is the same way how you write this. So again, you can write this as e to the power ln of 3 to the power 2 minus I. Now this can be written as e to the power ln 3 square minus 3 to the power I. Now, or this could have also been written like this. So let's take this power down here. So I end up getting e to the power 2 minus I times ln 3. Now this 2 will multiply to this ones and I will multiply to this one. So e to the power of 2 ln 3 into e to the power of minus I ln 3. Now this is nothing but 3 square. 2 will come back to this and it is 3 square into this. You'll write it like this. So cos of minus ln 3 plus I sine minus ln 3. So earlier I had told you something, 3 square cos of ln 3, because negative sign cos of negative is positive, so cos ln 3 minus I sine ln 3. So this is nothing but 9. 9 cos ln 3 minus 9 into I sine ln 3. This is your answer. Now let's move on to the eighth question, or we'll stop it here.